Collections will form the basis for a variety of our data structures. Numerous implementations are possible, but we will begin with an unsorted array implementation. But first, let's consider the collection as an abstract data type. Abstractly, we view a collection as an unordered group of elements. It is the lack of the importance of order that distinguishes a general collection from a list. There are three fundamental operations. The first involves adding an element, the second removing one, and the third determining whether a collection contains a particular element. A variety of implementations are possible, including using an array or a linked list that is either unsorted or sorted. From these implementations, sets and bags can be implemented, and once we consider order, lists as well. This UML diagram describes the interfaces and classes we will discuss. At the top is the collection interface that defines the three operations in the abstract data type. We will only consider one unsorted implementation, one that uses an array. The sorted interface will restrict the type of elements to elements that have a defined order. And in subsequent videos, we will discuss how a sorted implementation can be done using an array and also a linked list. Because an unsorted array is the simplest, we begin with it, starting with its add operation. Add is supplied the element to be added, and it returns whether the operation was successful. If the operation fails if the array is full, in which case false is returned. Otherwise, the new element is added at the end of the list and the instance variable size is incremented. And true is returned to indicate that the operation succeeded. Next, we consider how the remove operation using an unsorted array is implemented. Its signature is similar to the add operation. It is passed the element to be removed, and it returns whether the operation succeeded. The first step involves calling the private method find that performs a linear search. If it finds the element, it returns the subscript where it is located. Otherwise, it returns a -1. If it wasn't found, the remove method returns false. In our illustration, the 12 being searched for was found. First, size is decremented, and then the last element is moved into the empty slot where the element was removed. Finally, true is returned to indicate that the operation succeeded.